So this is my group members, Amira Adani, Nur Atira and Wan Nur Kistina.
Hi and Assalamualaikum. I'm going to present about the introduction of infrared radiation and thermal imaging. So, infrared are part of electromagnetic spectrum where people encounter infrared every day. But human eye cannot see it, but we still can detect it as a heat. Then in thermal imaging, some objects that are so hot it can emit visible light, such as fire, while other objects like human, we only can emit infrared since we are not as hot in temperature. Even our eye can see the infrared. There has an instrument was created that can sense infrared such as night vision goggles or night vision camera that allow us to see the infrared that emit from the warm object. So the temperature for image are in degrees Fahrenheit. So then next, the thermography is an imaging method that based on the temperature readings that allowing non-intrusive inspection of plant equipment and facilities, where it works by detecting the level of IR emitted by an observed body.
Now we go to the explanation of relevant scientific instrument. First, we have infrared camera, the mapping of isotherm over a component surface using heat-sensitive device that is known as infrared thermography. And infrared cameras can scan the component surface and record any changes in temperature. Defects are easily identified by their appearance as hot and cold spots that can be quickly recognized. It is frequently necessary to preheat the component being inspected before beginning, and the thermography is a non-contact technique that offers quick visual qualitative information regarding a material's structural integrity. It is used to verify a part of alignment and monitor the quality of concrete and also composite material. So next we have thermographic camera. It is similar to infrared camera just now, but thermographic camera often diffract radiation between range of 9,000 until 14,000 nanometer long infrared region of electromagnetic spectrum, and it creates thermogram which are photograph of that radiation. Now for future development and innovation in thermography. We have infrared thermography in sport medicine, which is the first one, medical infrared thermography (MIT), that is used for analyzing physiological function related to skin temperature. Next, we have remote sensing for human body temperature, such as in identifying a person with fever. And next, we also have the 3D thermography based on the combination of active visual 3D imaging technology and passive thermal imaging technology. The potential benefit of this system in medical application is for detection of the breast cancer. So for other future development and innovation in thermography, it can be concluded that while IRT is a useful tool for the characterization of defect in the building sector, currently the focus of IRT research and development is on the development of the highest number of pixels with a FPA structure with integrated electronic for signal readout and elaboration with working temperature close to room temperature and with high uniformity. Next, we also have thermal imaging technology that has recently advanced to offer portable, lightweight system that record high-resolution digital images with high temperature and spatial detail. So this factor make IRT application in research of both captive and wild mammals abundant.
Detailed exploration on thermography Infrared thermography is a valuable tool for condition monitoring and preventive maintenance. Not only does it allow you to detect thermal abnormalities of machines, but it lets you do so in a non-intrusive, hands-off way while getting results in real time. Thermographers usually employ one of three methods when performing thermal inspections: comparative, baseline, and thermal trending. Determining which method to use comes down to the type of equipment you are testing and the type of data you want to see. Comparative thermography. Comparative thermography is used to determine the temperature of components under similar conditions, identifying hidden issues and extracting valuable information. It can be whether qualitative or quantitative, with quantitative inspections measuring exact temperature or distribution. Modern thermography is primarily used in industrial and mechanical domains. So for baseline thermography establishes a reference point for an asset by gauging its temperature during normal operation. By comparing this baseline with subsequent thermal images, potential issues can be identified early. It's recommended to establish baselines for all vital assets when they are new or right after repairs to facilitate proactive maintenance. Thermal trending thermography. Thermal trending thermography tracks temperature variations within a component or assets across time, resembling trend analysis. It is specifically useful for examining mechanical equipment with intricate thermal patterns or gradual thermal shifts. For instance, monitoring the high temperature refractory insulation in a boiler over time helps establish a maintenance plan that reduces downtime effectively.
So next is the example of real-world implementation of thermography. The first is mechanical equipment. The use of thermal image is to detecting the infrared thermography. With this technology, the operator can validate the normal operation of machinery and equipment. By this technology also, it can locate the thermal anomalies that may be the sign of defect or problem in the machine and system. Then the next is electrical system. The thermography can detect the heating concentration or heat leak sources in electrical equipment by detecting the emitted infrared energy that may come from electrical circuit or electrical part, where the infrared energy converted into the temperature, which the higher temperature of equipment through an electrical current passes, the higher level of infrared detection will be. Lastly is thermography building application. In this application, the thermography provides a thermal image that includes the accurate temperature data to building aspect. And it also provides with important information about the insulation condition, moisture ingress, mold development, electrical faults, the presence of thermal breach, and the condition of HVAC system. By this application, the thermal imaging can indicate the potential problem and defect within the heat spread of the building. Then ALEX, water ingress point, and heat loss area or roofing can be highlighted easily with this thermal imaging. That's all from me.
Potential benefits of thermography. There are four: early detection of problems, enhanced equipment lifespan, applicate safety, improvements in energy efficiency. So I will be explain the benefits on next slide. Early detection of problems. Infrared thermography able to detect issues at its early stage before it leads to a bigger mess. The technology is highly sensitive and accurate, which enables experts to identify changes in temperature patterns and rectify potential issues before they become severe. These early detections may save costs by preventing any damages of equipment and facilities, and enhancement equipment lifespan. The use of infrared thermography in maintenance and inspection can expand the lifespan of equipment. Equipment and facilities that are often expected by infrared thermography can operate at optimal conditions for a more extended period. Infrared thermography can detect issues such as overheating and other problems that might lead to equipment damage or failure. Thermography also can upgrade safety by detecting potential fire hazards, electrical faults, and gas leaks, amongst others. By frequently detecting and managing these issues, infrared thermography may prevent accidents, loss of life, and property damages. Improvements in energy efficiency by identifying areas of energy loss that result in high energy consumption. Infrared thermography can help make facilities more energy efficient and lower their energy bills. Building owner and maintenance staff can lower energy costs and carbon emissions by making energy-saving adjustments, such as identifying areas of insulation and air leakage.
So, in conclusion, thermography can detect object or phenomena without making any physical contact. So, by these advantages, the thermography can apply in any situation where contact may not be feasible or where contactless measurements are essential for safety reasons. So, that's all from us.